Hello everyone. In last lectures we already studied the purpose of Banker's algorithm. It is used for multiple instances of resource type. Banker's algorithm is a deadlock avoidance algorithm. We studied different data structure required to execute Banker's algorithm, and this algorithm contains two algorithms, that is safety algorithm and resource request algorithm. Now in this lecture we are going to study how to apply this Banker's algorithm on given system. So the learning outcome of this session are, at the end of this session student will be able to apply Banker's algorithm for given set of processes and resources. Now consider a system with 5 processes P0 through P4 and 3 resource types A, B and C. Resource type A has 10 instances, B has 5 instances and C has 7 instances. So as we know, we have total 3 resources A, B, C with 10, 5 and 7 instances. So let us consider at time t0 the following snapshot of the system has been taken. This snapshot contains processes P0 to P4 and how many instances of each resources are allocated to each process. It contains the maximum need required for each process and it contains the available matrix. Now what is allocation matrix? Allocation matrix gives the number of instances of resources allocated to each process. So as we can see here, for process P0, one instance of resource type B is allocated. For process P1, 2 instances of resource type A are allocated. For P2, 3 instances of A and 2 instances of C are allocated. For process P3, 2 instances of A, 1 instance of B and 1 instance of C are allocated. And for process P4, only 2 instances of C are allocated. Now what is this max matrix? It shows that the maximum need that process may request in near future for completion of its execution. So that is what the maximum instances that process may request. And available matrix is what? Available matrix is calculated by subtracting the total instances minus the number of instances allocated. So now available instances of resource type A is 3, means why it is 3? Because 2 are allocated to P1, 3 are allocated to P2, 2 are allocated to P3. So total 7 instances are allocated out of 10. So that's why 10 minus 7, 3 are now available. Similarly for resource type B, from 5 instances, 2 instances are allocated, 1 to P0 and 1 to P3. So 5 minus 2, 3 are available. Similarly for C, from 7 instances, 2 are allocated to P2, 1 is allocated to P3 and 2 is allocated to P4. So 7 minus 5, only 2 instances are available. So this is the snapshot at time t0 for all the processes and the resources. Now we have to first apply safety algorithm, but before applying safety algorithm we need to calculate need matrix. So need matrix is calculated as max minus allocation. We have max matrix, we have allocation matrix. We can calculate need by max minus allocation, like 7 minus 0, 7, 5 minus 1, 4, 3 minus 0, 3, 3 minus 2, 1, 2 minus 0, 2, 2 minus 0, 2, 9 minus 3, 6, 0 minus 0, 0, 2 minus 2, 0, 2 minus 2, 0, 2 minus 1, 1, 2 minus 1, 1, and 4 minus 0, 4, 3 minus 0, 3 and 3 minus 2, 1. So in this way the need matrix is calculated for each and every process. Now we have to apply safety algorithm. So for safety algorithm, first we have to consider the available matrix. Now the available matrix is A equal to 3, B equal to 3 and C equal to 2, means 3 instances of A, 3 instances of B, 2 instances of C are now available. We have a pseudocode for that algorithm where initially we have to consider 2 vectors, work and finish. Work will be initialized to available and all finish of I will be set to false. We have a need matrix. Okay, so to apply this safety algorithm here, I constructed one table for better understanding. So here work is initialized to available and all finish of I are initially false. So as shown here, the process for process P0, now work is what? 332. Check need 743 for process P0, less than, whether it is less than equal to work, that is 332. Condition is false. So work will remain as it is, finish of I will remain false. Now second, increment I, go to process P1, check its need, whether its need is less than work, 1 to 2 less than 3, 3, 2, condition is true. So now work is modified by adding its allocation matrix into it. So 332 plus 200, it becomes 532 and finish of I becomes true. Now the next process P2, work becomes now 532, check its need 600 is less than equal to 532, condition is false, so work remains as it is and finish of I is also false. Then for P3, check need 011 less than equal to 532, condition is true, work is equal to 532 plus 211 743, condition is true. For P4, now work becomes 743, check 431 less than 743, yes, condition is true. So modify the work by adding its allocation. Now work becomes 745 and this is marked as a true. Now all processes are traced, but P0 and P2 finish of I is still false. So again check either P0 or P2. Here we consider P2, check 745 less than 745 is the work. Check its need 600, it is less than 745, yes, condition is true. So work equal to 745 plus 302, condition becomes true. Now for P0, work is 1047, check 743 is less than 1047, condition is true. So work is modified now and finish of I is marked as a true. Now as we can see, for all processes finish of I is marked as a true. So we can say that after applying this safety algorithm, system is in safe state with safe sequence P1, P3, P4, P2, P0. Okay, so here the system is in safe state with safe sequence. So by applying this safety algorithm, we claim that the system is currently in safe state with the safe sequence P1, P3, P4, P2, P0 and it satisfies the safety criteria. Now suppose system is in now safe state. Now suppose process P1 make one additional instance of resource type A, 0 instance of resource type B and 2 instance of resource type C. So now request 1 becomes 102. Now to check whether this request can be granted or not, we have to run the resource request algorithm, where the first step is check whether the request made by the process is less than need or not. Means check 102 is less than equal to 122. Yes, condition is true. Now go to step 2. Check whether that request is less than available. Yes, 102 is less than 332, condition is true. Now from these two steps we can say that this request has been fulfilled and allocate the resource to P1. Now for allocating this 102 to process P1, the some data structure get modified. First is available will get modified because we have to make available equal to available minus request 1, that is 332 minus 102, it becomes now 230. Allocation 1 equal to allocation 1 plus request 1, 200 plus 102, it becomes 302. Need 1 equal to need 1 minus request 1, 122 minus 102 equal to 020. So we now by modifying this matrix we now arrive at the new state. So the new state of the system is P1 allocation is 302, its need is 020 and now the available matrix is 230. Now once we get this new state of system, again we have to check whether this system is in safe state or not, and for that purpose again we have to apply the safety algorithm with work equal to 230. So again we are going to apply the same safety algorithm here with work equal to 230. Now check need of the first process, need is 743 less than 230, false, work remains as it is, finish of I is false. For P1 need is 020, it is less than 230, so work is 230 plus 302, that is 532 and it becomes true, finish of I is true. For P2 now work is 532 check its need. 600 is less than 532, condition is false, so work remains as it is and finish of I becomes false. For P3, now work is 532 only, so its need is 011, which is less than 532. Yes, then work will be modified by adding its allocation matrix. It becomes 743 and finish of I is equal to true. Same for P4. Now work is 743, need is 431, which is less than 743. It modifies work by allocation by adding allocation matrix. It becomes now 745 and finish of I becomes true. Now again, though we gone through all the processes, process P0 and P2 has finish of I equal to false. So again consider P0, check whether its need 743 is less than 745. Yes, condition is true, so it modify work by adding its allocation matrix. Now work becomes 755 and finish of I becomes true. For P2, 755, 020 is less than 755. Yes, work is now modified. It becomes 1057 and finish of I is equal to true. Now, as we get all finish of I equal to true, we can say that after allocation of requested resource to process P1, system is in safe state with safe sequence P1, P3, P4, P0 and P2 as shown here. Okay, so this is in the safe state. Now as we check that system is in safe state, now consider that process P4 make again request for 3 instance of resource type A, 3 instance of resource type B and 0 instance of resource type C. So request 4 becomes 330. So using the resource allocation algorithm, again check whether this request is less than equal to 4, that 330 is less than equal to need 431. This is true. Check request 4 is less than equal to available, request 4 is 330, check whether it is less than available, available is 230, no, it is not less than. So this condition is false. As this condition is false, we can say that we cannot allocate these resources to process P4 because it doesn't satisfy the second condition, that request 4 less than equal to available. So process has to wait in this case. Okay, so before allocating the resources to the process, it must check whether it is possible to allocate the resource or not. And once it is possible to allocate, after allocation, check whether that system is in safe state or not. So by following this mechanism, the deadlock can be avoided in the system. And this is what the banker's algorithm, which is used for avoiding a deadlock in multiple instance of resource type. So this is what the banker's algorithm. These are the references. Thank you.